Code reviews are a critical part of the software development process, and there are many, many different ways to do code review. The basic idea, though, is to inspect code after it's been written and before you decide to think of it as done. You can kind of think of this as the editing part of the writing process. So if you're in the middle of a large writing project, you end up having a first draft and then going back and spending most of the time editing that draft down to exactly and only what you want to say. The same sort of thing happens in software development. We just think of that as the code review process. And again, the idea is to have as many people looking at this as possible to make sure that it is actually what you're hoping to do, what you're hoping to produce, the most efficient form, most eloquent form of what it is that you need. Now, in the real world, you don't have that ability to have tons of people looking at every single line of code in all of your systems, and so there's levels of code review. We'll cover 6 of them here, and the idea behind this is kind of going from the least invasive, easiest to do, to the more complex, harder to do techniques for code review. It is worth at least commenting briefly on Linus's law, which is this notion that given enough eyeballs, all bugs are shallow. There have been studies looking at this to see if that's actually true, and it's not true in the sort of extreme events, because even if you have tons and tons of people looking at a piece of software, you may still have lots of bugs in it, or serious bugs in it in particular. But it is kind of true when you start getting to source code that hasn't been reviewed at all, right? So if you have dozens of people looking at a piece of source code, that is way better than having just 2 or 3. But if you end up in a situation where it's like thousands of people looking at the code, I'm not sure that that's all that much better than having just a couple dozen. It's very difficult to say. Some of the studies that I've seen are on fairly small projects and limited in scope. But it's an interesting idea that for a long time has driven open source software processes to try and get as many people looking at this as possible. Okay, so the first element of code review that we're going to talk about is this notion of an over-the-shoulder system. And I don't have a separate slide for this simply because it is very, very simple. It's a simple sanity check. So most of the time if you work in an environment where other programmers are also working, you can call them over for a quick sanity check of a use of an API or a question about the source code that you're working on. And this happens all the time. It's very, very common. This is one of the things that I think is most difficult about the change from an academic coding environment where you're expected to do kind of your own work to a professional environment where people are collaborating to build a product together. Over-the-shoulder code review happens all the time. There's also a notion of like a cardboard programmer, where as a part of the process of describing the problem you're trying to solve to a programmer who's standing over your shoulder, you see the problem and you see the solution to the problem that you're trying to address, and you don't even need their input. And the analogy here is that person, that other programmer who's standing over your shoulder, might as well have just been a cardboard cutout of a programmer and not even present. So sometimes, much like in the editing process for writing, if you are just reading your code back to yourself, you will spot the problem as you're trying to describe it. I also wanted to briefly say this is a very useful tool for a sanity check, simply because if you are nervous about something, you probably shouldn't do it. That's number one rule of working with any kind of a power tool is if you don't feel comfortable using it, don't. Same sort of thing should happen with code reviews. If you don't feel comfortable checking something into a repository, don't. Get a sanity check. Have at least somebody else look at it before you do something like that. Okay, so let's move on to tool-supported code review systems using version control. Version control system is essentially a piece of software that helps you track changes to source code. This is really critical because if you can't do that, you're not going to be able to revert mistakes very easily. You may not be able to handle different versions of deployed software, or possibly software that has to be deployed on multiple product lines. So you can imagine an application that has to be deployed on say a phone, a laptop, and then also on a server, or a phone, a tablet, and a desktop, or something like that. There's probably code that's shared from each of those applications, and code that's not shared across those product lines. And so it's difficult to update source code without a version control system to help you manage that shared code. And there are many different ways of doing this. There are basically break down into two high-level categories. You can have a centralized system like Subversion or CVS. These are older and not as commonly used today, but they are still out there in industry. Or you can have a distributed system like Git, Mercurial, Bazaar. Perforce is another product that you can purchase. It's a distributed version control system, somewhat similar to this. Each of these have tools that are basically common across the entire product line for merging source code from another repository or highlighting mistakes, diffing multiple versions that have been checked in, that sort of thing. Normally I would ask students in the class who's heard of them and who's used them and what experiences they have. Unfortunately, we can't quite go into some of those details there, but it is worth talking to people and seeing which ones they've used, especially in an academic setting, because these tools are not commonly taught as an explicit part of a class. And so if you only have experience as an academic programmer and you go off into industry, you often have to pick these tools up kind of from scratch without really having a whole lot of formal training in what they are and how they work. Okay, so a commit-based code review is essentially founded on the idea that you want to evaluate source code right before you merge it into the main branch of the system. And this is a good time to do it because once it's merged into the branch, there's a history there. There's like a maintenance responsibility there. Usually a commit-based code review is done through some kind of a gatekeeping process. Either you'll have an individual gatekeeper who just manages all of the commits and verifies each one is kind of what they're expecting it will be. Sometimes you'll have a group gatekeeping process that could include discussions over some kind of a communications tool. Sometimes it's email, sometimes it's Slack, or sometimes it's actually in the version control repository itself. But in both cases, the idea is to have somebody make a decision about whether or not the code is worthy of being merged prior to letting it be merged. Now, this is a very flexible, proven model, particularly for distributed and open source teams. It's the kind of thing that's been widely used in industry, and there's pretty well-known limitations. Essentially, that the quality of the code review depends very, very heavily on the gatekeeper. And if the gatekeeper is better at some parts of the system than other parts, or has some domain knowledge that is stronger in some areas than in other areas, then you may have an uneven process for doing code reviews, and that could apply to the entire system depending on how you've broken it up. So, yeah. You could also have a process that performs a code review like this only when you're merging branches into the main development branch, and then have the other sub-branches, the non-main branches, be more lax, where you can just commit to feature branches very easily, but then when you merge it into the main development branch, it has to be reviewed quite thoroughly. This is sort of similar to what we're talking about with just pure commit-based code reviews, but it's a little bit more domain-specific or organization-specific, I should say. All right, let's talk a little bit about semantic versioning, because once you start getting into the question of what version a tool is or what version the source code is, you need to have a way of actually identifying the version. Usually that's done through a number, and semantic versioning is a process for assigning meaning, some sort of semantic meaning, to the various elements of that version number. It's not the only way that you could do this sort of thing, and it's not covered in the textbook. This is something that I'm introducing simply because I think you'll run into this problem eventually, and I want you to at least see one example of how to solve it. Typically, in semantic versioning, you have three numbers: a major number, a minor number, and a patch number, and you would increment them according to the following heuristics. So you'd increment the major number if you've ever made an incompatible API change, right? Something that would make backwards compatibility impossible for anyone who's currently using the previous version of that software. And then you would increment the minor version when you're adding functionality in a backwards compatible fashion, meaning that it's a new functionality, but it's backwards compatible with the previous version, and there shouldn't be problems with any of the features that you've added prior to that. Or you would increment the patch version, right? So that would be when you've got some kind of a backwards compatible bug fix, but it's essentially not introducing a new feature of any kind. There are, of course, many other labels for pre-release builds, alpha builds, metadata that you can add to the major minor patch format. You can find more information about those on semver.org. A lot of projects don't use this kind of system for versioning. I think it's a pretty reasonable way to do things, but it is not the only reasonable way to do things. There are plenty of other approaches that you might take. Okay, let's get back to code review processes. The last one I want to talk about in this short section is walkthroughs. And walkthroughs are highly variable in terms of structure and format. Typically, they all have at least this in common, though. The code author themselves presenting an overview of the software that's being reviewed. Then some form of discussion amongst the participants about the one part of that software that needs to be reviewed in detail. If there are errors or suggested changes, the improvements are typically noted and written down, sometimes by an explicit recorder, sometimes by the author of the code themselves. And afterwards, the notes are going to be compiled into some kind of a report or a document, even if it is just a text file in an email or a text file in the commit that addresses the changes necessary from the walkthrough. But you have to have some kind of a documented report of the walkthrough. And then this documentation will serve, this report will serve as documentation of the changes, right? So that you'd be able to go back and if you had new people join the team or if people leave the team, you don't have that loss of institutional knowledge. You want to make sure that it's something that's documented somewhere so that you don't make the same mistakes that you may have just fixed. So the objectives are essentially we want to evaluate the software artifact explicitly for, one, finding problems, right? Defects, omissions, contradictions, that sort of thing. But also, two, improving the implementation, right? Making it more idiomatic, choosing alternative algorithms or implementations or APIs, or choosing a more appropriate piece there. And then three, and a third goal of doing these walkthroughs is educating participants. Now that might mean educating participants on language idioms or language techniques or algorithmic techniques. But more often, the educating participants is really just trying to show participants, meaning other engineers of the organization, what is actually happening in other parts of the software that they may not get a chance to touch, right? That could include domain knowledge for the problem you're trying to solve, but more than likely it's intended to just give them a richer understanding of the source code as a whole, rather than to just leave them wondering the same way that a user might, what does that module actually do under the covers? Like, how does this thing actually work? Right. Now, a walkthrough can point out a lot of efficiency, readability problems in a code, modularity problems in design, or testable or untestable problems with design specifications that are related to idioms within the source code. And so it's a very, very effective tool in this kind of an environment. It's expensive, though, right? Because you are still getting all these people together to discuss a single piece of code in some detail. Usually it's going to take somewhere between 30 and 90 minutes. Probably don't want to go very much more than that. Now, this is still more informal than software inspections, which we'll talk about in the next section.